In this video, let's understand about virtual wire pair concept in FortiGate firewall. All right. So a virtual wire pair consists of two interfaces that doesn't have any IP addresses configured to it, and they are treated like a transparent mode. Okay. So all traffic received by one interface in the virtual wire pair can be forwarded to the other interface, and provided a virtual wire pair firewall policy allows this traffic. Like basically, whatever traffic that's coming in one interface that is sent to the other interface, and in order to pass this from one interface to other interface, you need to have a special policy. Okay, we refer it as like virtual wire pair firewall policy. All right. So the virtual wire is also referred as a bump in the wire or transparent inline. Okay. So like all other vendors is also having the same concept. Like if you remember in our Palo Alto firewall, we have seen like vWire, right? And also in Cisco, it's like transparent. So the virtual wire logically binds two Ethernet or two interfaces together, allowing all traffic to pass through it. Okay, and virtual wire can be inserted into existing topology without making any changes to it. Like mostly, it is used in certain requirement. Like there may be some requirement there is an existing topology, existing network. Okay, you don't want to disturb the existing network, or you don't want to modify the topology, because whenever you, in general, like whenever you add a firewall, a device in the network, you need to configure IP addresses, you need to plan for subnets and all, right? So there may be some requirement where you want to keep your firewall in the traffic flow, but you don't want to disturb the existing setup, like you don't want to add a new IP addresses and all. So in that cases, like we'll be going for a virtual wire. All right. Let's see in our lab to understand more in detail about it. So in our lab, to understand about virtual wire pair, we have taken a simple topology. Like we have one Windows machine that is connected to the internet. Okay, so basically to the NAT network, and maybe for your reference to add, um, I can just make it as like it is 10.0.137.0/24. All right. So this is what it is overall. And especially here, the gateway of this one is dot 254 dot 254. And think here I have configured the IP address like 137, I believe. So actually, I made it as a DHCP. No, I have not made it as a DHCP. Like IP config 137. Maybe I can enlarge it. All right, it's 10.0.137.137. So, like I said, in there may be some situations or requirement in your environment where there will be an existing setup. All right, so you don't want to disturb it by placing a firewall, a new product, a new firewall in between, because just imagine, like means it's a very simple topology, but in your environment maybe you're having a big setup, like, and if in case you're placing a new firewall somewhere. Okay, I then what we need to do, like basically when you put a new firewall in between the traffic flow, in between anywhere in a new setup, or maybe already you may be having a firewall someplace, but as per your environment requirement, you're adding a firewall somewhere, the new place. Okay, then what you'll do, you should plan for IP segments, then you'll be configuring IP addresses accordingly. So when you make changes in the IP addresses, like you put a new firewall, so you basically like existing, like there is only one connectivity, right? But when you put a firewall here, and if you go for an IP segmentation, then you'll be having a different segments, this side you have a different segment. Basically, you're disturbing the existing network, right? In order to avoid it, this kind of a requirement should come, like you want to explore this feature of a firewall by putting here without making any changes to the existing setup. Okay, no IP, nothing. So basically, you're not making any changes in the IP addresses. You're not disturbing the existing topology. All right. So when I say you're not disturbing the existing topology, like without changing the IP addresses. All right. So how it can be done? Like instead of having a direct connectivity to internet, I'll just delete this one and I'll bring this firewall in between. I will just connect this PC to port number 2 and will connect port number 3 to the other side net. Okay. So what does it mean? Like we placed a firewall in the existing topology, but we are not going to configure any IP addresses for this interface, or we're not going to make any routes, nothing here. Instead, what we are going to tell to firewall, hey, I have placed you like in the ongoing or existing topology. Okay, you're not going to make any changes in these configurations. Instead, we are just going to do virtual wire, right? When I say virtual wire, logically you are um, you know cutting this, logically you are cutting the existing wire and you're putting one connection here and the other connection here. Okay, so physically, yes, of course, it's different connectivity. It's a different connectivity that's connected to two different ports. But logically, how it works, whatever traffic that's coming on port 2, as soon as it reaches firewall, it will go out here in port 3. Okay. So that you're not making any changes in the IP addresses. You're not going to configure any IP addresses and no routes is required. I'll show you how it is. Okay, so as said earlier, you have this IP address and you have a connectivity to internet also. Maybe I didn't showed you that you had an internet connectivity. That's fine, but because I have directly connected, logically it should work, right? Fine. So I'll just go to my FortiGate firewall and show you how to configure the virtual wire. So here I have came. So under interface, go to create, and if you see here under interface zone, there is a option like virtual wire pair, right? Select this option. You can give any name to it. I just name it virtual wire. Okay. And must enter. Okay. Maybe I'll put V wire. Okay. All right. So interface we need to define like what are all the interfaces that is going to take part in the virtual wire pair. So one is port 2. Basically, whenever it comes to virtual wire pair, right, there should be two interfaces. Like because we are cutting one physical interface and logically we are binding it, right? So we should have a two connectivity. So that port 2 and port 3, so that whatever comes on port 2 will be sent to port through port 3, and like based on how we define, like whatever coming again in port 3 should forward to port 2, forward out to port 2. So I have created it. So if you scroll down, you'll be seeing this one like virtual wire. Okay, just scroll down a little and you would see the physical status of this port is up. All right. So now we place this firewall and we have configured port 2 and port 3 part of a virtual wire, so that whatever communication or traffic that's coming this way, it should be forwarded through the port 3. Okay. So logically, it comes from two different ports and passing through a device. Sorry, technically or physically, the traffic is passing through one port of a device and going out of the other port of the device. Logically, it act like it's going through one single wire only. Okay, the same single wire concept. That's what we refer as like virtual wire. All right. So now we configured virtual wire, and there is one important thing we need to do. Like if you remember in the PPT, it mentioned like we need to have a valid virtual wire security policy. Okay. So if in order to do so, just go to policy and object, and if you remember, usually we'll go here to the firewall policy, right? But there is something like firewall virtual wire pair policy. Okay, this comes in picture whenever you are configuring the virtual wire. All right, so the policy which we refer is not the ordinary firewall policy. When you configure for a virtual wire, we should configure the virtual wire firewall policy. Okay, this is what it is. So here, like you don't see any defined policy. We need to create a new one. Like I'll put create and I'll put one name to it, vwire1. Okay, so as soon as I create one, like it automatically taken the virtual wire that I have created in this device, because currently we have only one, right? So if you have multiple, maybe when you once you put this plus, you'll be seeing the list of vwire that we have already created. But as per our topology or our lab thing, we have only one vwire, so that it's showing the same. Okay, all right. And when it comes to the rule we refine, see, this is what it is. Like what it is telling, how we want to have it. Like when whatever traffic like that's coming from this side, either you want to allow only the traffic coming from this side on port 2 pass towards port 3, or you want to allow a traffic flow that's coming from the other side, like through port 3 towards on port 2, or you want to allow a bidirection like port 3 to sorry port 2 to port 3 out and port 3 to port 2 in. Okay, that's what it is mentioned here, like the symbol. Okay, based on that you can define it. If you want to have only from inside to outside, you can go with this, means basically from physical port to 2 goes outside through port 3, that's it, it will not allow the incoming. And if you want to allow only the incoming, like from outside to inside, you can mention this direction, so that whatever that's coming from port 3 and going towards port 2, it will be allowed. Okay, I'll just repeat. See, if I put this option, it refers that whatever traffic that comes from port 2 passes to port 3, it is allowed. Okay, if something is coming in this direction, it will not allow. All right, and if in case I put it in this direction, it means that whenever a traffic that's coming from port 3, like this direction, means that's what the direction talks about. And if it goes towards this side through port 2, it is allowed. All right. So means it's set to accept here, so that it's allowed. If you want to block it, you can do it. Okay. And like if you select this option, then bidirectional, both in and out is allowed. Okay, so in our lab, let's have both side communication, so that I'm just going with that. I don't want to have multiple policies for it. Maybe in a production environment, it depends on your requirement or how it is deployed. Okay, either you can have a single side or the other side, or two-way. All right, so source I'll put all only, destination also I'll put all, and service as well I'll put all. Accept. NAT is not required because we are not going to configure any IP addresses in it. We'll save it. That's it. So the required the virtual wire firewall policy is now readily available. Now let's go back to our topology and let's go back to this PC. We'll try to connect to internet. Let's try to ping to 8.8.8.8. It should reach. See, we are getting a response. Like basically, how does it work? The request it comes here through port 2. Okay, we have binded this like port 2 and port 3 as a virtual wire. Okay, though physically it goes through this box, it act logically that as a single wire only. Okay, we also have a valid virtual wire policy to allow the transaction on a bidirectional way, so that when a traffic is coming in this direction, it is allowed. Okay, all right. And also like if you want to initiate some other traffic also, it would work. Can minimize it. Like maybe any traffic, any web traffic, like YouTube or Wikipedia. Yeah, it's working, right? Even YouTube is loading now. Okay, even Wikipedia loaded. You can see that, yeah, YouTube is also loaded, right? Okay, so it means that we are able to connect to internet. Okay, all right. Now let's come back here to the FortiGate dashboard, and if you see the source information, see all the transaction details are available here. So it to show you that we make use of this virtual wire firewall policy, and the traffic passes through it. So okay, so this is how we can configure the virtual wire. Like see, all the session logs are available here. So basically, as said, the virtual wire configuration will be using this virtual wire when we don't want to disturb the existing topology, but still we want to place the device in between. Okay. All right.